So now we're going to start making isobars and realizing how they're relevant for meteorologists. So in this case, you can see here, this is 2011 Hurricane Irene. You can see this counterclockwise flow around this low pressure center. Look at these arrows. You can see that they're all pointing in this counterclockwise direction. Also, these are higher pressures out here, lower, 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 so the wind is moving from the areas of high pressure to low pressure, but because the Coriolis force, they make right turns. So now I happen to save a pressure map of Hurricane Irene. These are all in millibars. If you see numbers that are near 1013, that's pretty much standard atmospheric pressure at sea level. 1013.25 is standard atmospheric pressure at sea level in millibars. So what we're going to do is we're going to use the same techniques that the meteorologists use. We're going to basically make isobars. Now, iso means Greek, iso in Greek is equal. Bar means pressure. So we're going to basically draw lines that represent equal pressure. So it's kind of like connected dots in a way, but we're connecting the same numbers to the same number. So for example, I see a 1012 right here. Another 1012 right over here. Now I don't see another 1012 till I get right over here, but this 1013 and this 1010, we know that somewhere in the middle of these must be a 1012. And I'm going to draw that dot a little closer to the 1013 than the 1010. And I'll connect my line right through them. So even if you don't have visible 1012s on your map, as long as you have evidence to support, like here there's 1008, 1013, there's evidence to support that there should be a 1012 right here. So we'll connect that line, this one, and just keep going right up in this area. So this 1012 is a little bit misleading because it's usually not that easy, but I just wanted to give you the general understanding. So now the next line that we have to draw is 1008. Now I see 1008 over here, that's easy. Now we know that there's 1008 right between 1007 and 1010. Getting a little hard to draw and fit that line in there, but you get the picture. 1008. Now there's not another 1008 visible on the map anywhere, but you must connect this line and finish it off the map. Isobars are not allowed to split. They're not allowed to do this. And they're not just allowed to just terminate randomly on the map. So we have 1008, and we know that there's 1008 in between 1001 and 1010. So we're going to run right up closer to the 1010 than 1001. This is a little hard to read, but it actually says 1007. This blue line, remember, represents 1012. So we know that 1008 is going to come up over here. And since this is 1007, we'll continue our 1008 line right over there. And you want to make sure that you label your isobars appropriately. So in this case, we know that this is 1008. This is obviously 1012. And we're going to work our increments in fours. So 1012, 1008. The next one's going to be 1004. I don't see 1004 on this map, but we need to draw one because we know there's evidence to support that because there's 1002 and there's 1007. So we're basically going to pick a spot to sort of split those. And now we need to figure out where the 1004 is going to go. Remember, this line over here represents 1008. This is 1002. And since 1004 sits between 1002 and 1008, we know that there must be the isobar that represents 1004. This is 1001, so I got to go to this side because this line represents 1008. And keep following this down as we interpolate this line. 1003, 1007, we know that 1004 has to be a little bit closer to those. 1006 and 1002. We know that 1004 is right between those. And now that we ran out of information, we ran this line off the map, and that's perfectly all right. So we could already see how this is starting to shape up. We know that our wind vectors would be, our wind would be rushing from high to low, but it makes a right turn. High rushing to low, but it makes a right turn. Up here by New Jersey, we see high moves to low, but it makes a right turn. So eventually you're going to see that all these wind vectors create this counterclockwise flow. Now here's the deal. When we get this area of 1001 to 984, that's a big pressure gradient force. So the wind is going to be much stronger and really spinning counterclockwise around these low pressure centers.